Now we are asked to find the points on the curve C where the tangent is horizontal or vertical. So how are we going to relate this horizontal and vertical nature along with the derivative? Well, we have already done the fact that if the derivative of a certain curve is equal to 0, then that means it has a horizontal tangent, right? And if the derivative is equal to infinity, then you will get a vertical tangent, right? Because basically this is the tan theta value of this theta angle in a line, right? That comes with the definition of derivative. And if you need more explanation, please tell me. I will do a separate video. I will go over it during the office hours, right? Okay, so what you have to remember is these two facts, right? If the derivative is equal to 0, then you will have a horizontal line, and if the derivative is infinity, you will get a vertical line. Basically, you don't have to even remember this because it comes naturally from the definition of the derivative. Okay, right? And we computed, or we come up with a certain equation that involves the derivatives of our parametric variable, right? Now remember, the curve is given like this, right, with respect to t, and this derivative, when you are saying the horizontal and vertical stuffs, that represents the derivative of y with respect to x, okay, not with respect to a different variable. So we have to compute the derivative of y with respect to x by the help of this chain rule that we learned, okay. And also we saw that this dt by dx can be written like this, right? So ultimately what we have is the derivative of y with respect to x can be written like this: the derivative of y with respect to d, this thing, divided by derivative of x with respect to t, right? Then from this equation, this is the kind of the main equation that you need, right? By looking at this equation, we can relate the terms to these two conditions, right? Say if the derivative is equal to 0, that means this value should be equal to 0. So if this is equal to 0, that means this value should be equal to 0. But there is a certain condition that this should not be equal to 0, and dx by dt should not be equal to 0, because if both are equal to 0, then the derivative will be an undefined case, right? And if you need the derivative of y with respect to x to be equal to infinity, then you need the denominator to be equal to 0, right? Dx by dt will be equal to 0, and we should not have the 0 in the numerator, right? And if this happens, then the numerator should not be equal to 0. So if our curves satisfies these conditions, then we can get the other direction, right? That means basically if we have this condition, we have this one, and if we have this condition, we have this one, which you can directly relate it with the horizontal and the vertical nature. So in the question it asks to find the points where tangent is horizontal or vertical. So basically what we need to do is we need to compute the required t values so that these conditions are satisfied, right? So from the given two equations we can compute the derivatives dy by dt and dx by dt, and by equating it to 0 you can obtain this relationship. That means when t is equal to 1 or negative 1, you will have the derivative of y with respect to x with respect to t to be equal to 0, and when t is equal to 0 you will get this one equals to 0, right? So, and also you should notice something: when t is equal to plus or minus 1, dx by dt is not equal to 0, right? Because this is the only situation where dx by dt is equal to 0. And also when this is 0, this will not be equal to 0, because the only situation that this becomes 0 is when t is equal to plus or minus 1. But this is not plus or minus 1, it is 0. So at t equals 0, this will be equal to 0 and at t equals plus or minus 1, this will be equal to 0. Now see, even in this relationship that we obtained before, only one term should be equal to 0. If both becomes equal to 0, then there will be a problem, right? Okay, so from putting all these things together, we can say that at t equals plus or minus 1, that means when this is equal to 0, our curve, the derivative of y with respect to x will be equal to 0. That means the curve will have a horizontal tangent at both these 2 points, right? So at both t equals 1 and t equals negative 1, curve has a horizontal tangent, right? And at this point, when the denominator of this equation becomes 0, curve will get a vertical tangent, right? So here you will get a vertical tangent, right? And then now we have some more information about our graph, right? That means we can think about a certain a shape for the curve C, right? Let's see whether we can kind of obtain a picture for this. Let's see how to interpret this information on our curve, right? Now these two were obtained from the previous calculation, and now here it says when t equals plus and minus 1, you will get a horizontal tangent. So how do we interpret that in our plot? So in order to interpret a horizontal line or a tangent, first of all we need to figure out the corresponding x and y value where this horizontal line exists, right? That means we need to figure out the corresponding x and y values for this t equals 1 and for t equals negative 1, right? And when t equals 1, you will get y. In order to obtain the x and y values, you need to substitute t equals 1 in this equation and this equation, right? So when you substitute 1 in here, you will get 1 minus 3, right, which is equal to negative 2. And then when you substitute 1 here, you will get x equals 1, and the same thing is applied to negative 1 as well. So when you substitute negative 1 here, you will get 2 and x will be equal to 1, right? See, now these two are the points that will have a 0 slope, or in fact a horizontal tangent, that is x equals 1 and negative 1, x equals 1 and positive 2. Sorry, this is also negative 2. So that means at x equals 1, at x equals 1, the curve will have two positions, right? Now clearly this is not a function, okay, because at a certain x value you cannot have two y values if it is a function, right? This is just a relationship between x and y, and not being a function does not mean that we can plot, right? Now say for example, we can of course plot a circle, right? But circle is not a function. See, at this point you have two corresponding y values, right? So in this x and y axis system, in x and y coordinate, it is not only the functions that we can plot any sort of a relationship between x and y, okay, right? So from that data or the information that we obtain from the second part, we can see that the curve will be of this nature, right? So now we can kind of obtain a exact shape for this curve, right? And also we know that at t equals 0, that means the x value is 0 and the y value is also 0. We should have a vertical tangent, right? So at 0, 0 point we need a vertical line, right? So here the tangent should be vertical. That means we can get a curve like this, right? Now there is some more fine tuning that you can do, well, because now at the moment what we know is we will have a curve like this in here, a curve like this in here, and a curve of this nature at this 0, 0 origin, right? But how about completing the rest? Because now for the remaining part we can even imagine curves like this, right? Because we don't know it yet. So in order to complete the remaining, we need the concave or the convex nature. We need to compute the concave or the convex nature of the graph, right? Then only we can draw a precise shape for the given curve, right? Okay, and I will do that in the next video.